All right, in this video we're going to learn about some special right triangles, which is going to lead into what we talk about next week with dealing with the unit circle. So the first thing to understand is we call these special right triangles because there's some unique and special relationships that exist between the different sides. So our first special right triangle is a 40, 45, 90 triangle is what we call this. And here the relationship is that we can call this side A, we could call this side A. And so for one, it's an equilateral triangle. So those two side lengths would be the same measurement. And if we know those two sides, the measure of the hypotenuse is just A times the square root of 2. So if we know that we're working with a special right triangle, it's 45, 45, 90, and one of those side lengths is 5, I know the hypotenuse is going to be 5 square root of 2. Over here, with what we call our second special right triangle is a 30, 60, 90 triangle. And for this one, we'll call our short leg A. So we have a short leg, a long leg, and then the hypotenuse. So the short leg is going to be across from the smallest angle. So it's across from the angle, that's 30 degrees. The hypotenuse is twice that size. Okay, so that's always the case for any 30, 60, 90 triangle. The hypotenuse will always be double whatever the short leg is. And then the side opposite the 60-degree angle, that's going to be our long leg. That's just going to be A times the square root of 3. So we're going to use this information to find some of these different trig ratios here. So on your guys' notes, you're going to be able to see this a little bit better. Oops, that moved down. Than what I'll be able to do. So you won't have to scroll up and down. You can just look at your own notes. All right, so let's look at this first one. So we're going to do A, D, and E together. And then I'm going to have you do B, C, and F on your own. So when you look at that special right triangle, we're trying to find the sine of 45 degrees. And by the way, we're trying to find the exact answers. That means we're doing this with leaving them as fractions. We're not going to do them as decimals. We are not going to use our calculators for these. So none of these notes we're going to use our calculators. We're going to strictly just base everything on those two special right triangles that we have at the top. All right, so again, sine of 45 degrees. If you remember from our previous lesson, we have that phrase SOHCAHTOA to keep track of those different trig ratios. So we know the sine of theta is the opposite over the hypotenuse. So in this case, theta is 45 degrees. And the opposite leg, if you look at your triangle, so the opposite leg is A, and the hypotenuse is A squared root of 2. Now we're going to simplify this. Now the A's cancel out, leaving us with 1 over the square root of 2. The square root of 2 is in our denominator, so we say it's 1 over the square root of 2. But then we have to do what we call rationalizing the denominator. We're going to multiply the top and bottom by that square root of 2. So when you do that, the numerator, 1 times square root of 2 is square root of 2. The denominator, square root of 2 times square root of 2, technically, yes, it is the square root of 4, which then is 2. So the square root of 2 times square root of 2 is just 2. So the sine of 45 degrees, we say, is square root 2 over 2. All right, let's do a trickier one. Let's look at cotangent of 30 degrees. So again, cotangent, that's one of those trig ratios we talked about yesterday. So we said the cotangent of theta yesterday. Remember, that's the reciprocal of the tangent function. Tangent, TOA. Tangent is opposite over the adjacent. So this would be the reciprocal of that, adjacent over the opposite leg. So let's look at, well, first off, I'll just write this down. Cotangent of 30 degrees. Let's look back up at the top here. So 30 degrees, that would be from the second triangle. So we're referencing this angle. And again, it's going to be the adjacent over the opposite leg. So the adjacent would be A squared root of 3. The opposite of leg would be just plain old A. So it would be A squared root of 3 over A. To simplify this one, the A's cancel out. So we say the cotangent of 30 degrees is just square root of 3. Let's do one more together. Secant of 60 degrees. So secant of 60 degrees, well, first off, let's review. Secant of theta, that's reciprocal of the cosine function. Cosine is ca adjacent over the hypotenuse, so this would be hypotenuse over the adjacent leg. So we're dealing with a secant of 60 degrees. Let's look back up, our 30, 60, 90 triangle. So now we're referencing this angle. So again, we're dealing with the hypotenuse, which is 2a, so it's going to be 2a over our adjacent leg, which is just a. And when we simplify that, the a's cancel out. So the secant of 60 degrees would be 2. So what I want you guys to do is do the same thing now to find the values for B, C, and F. Again, doing this without a calculator, just referencing and using those top two special right triangles. So go ahead, pause the video, and hit play when you're ready to check your answers. All right, let's look at the first one. How'd you do? Did you get square root of 3 over 2? If not, let's see where you made your mistake. So first off, we're trying to find the cosine of 30 degrees, which would be the adjacent over the hypotenuse. So in that triangle above, make sure that you're looking at the 30-degree angle, and the leg that's adjacent to that 30-degree angle would be the side that's a square root of 3. So that'd be your numerator. The hypotenuse is 2a. So again, the a's would cancel out, leaving us with just root 3 over 2. For the next one, for letter C, did you get square root of 3? If you did, great job. If you didn't, let's check to see where you made your mistake. So now, common mistake is that people forget to shift angles. So if you're working with the 30-degree angle, that might have been where your mistake was. We're dealing with the 60-degree angle, which is back on top. And so again, tangent is opposite over the adjacent, so the opposite leg would be a square root of 3. And the adjacent leg would just be a. So the a's end up canceling out, leaving us with just square root of 3. So tangent of 60 degrees is square root of 3. Now this last one, this would be out of those. It's very similar to the first one. It's a little bit, had one extra step that we had to do here. So let's see how to do that. So first off, again, cosecant is the hypotenuse over the opposite leg. The hypotenuse on that 30, 60, 90 triangle, again, looking at the 60-degree angle, so cosecant is 60 degrees. The hypotenuse is 2a. So the leg opposite the 60-degree angle is a root 3. So again, the a's cancel out. But we never want to leave a square root in the denominator. So remember what we did on letter A. We had to rationalize the denominator, so we have to rationalize the denominator here as well. We do that by multiplying by what is in the square root that's in the denominator. So we multiply the top and bottom by square root of 3. So you end up with 2 root 3 in the numerator, and square root of 3 times square root of 3 would just be 3. So that would be your answer for letter F. All right. Now we're going to go back and use those special right triangles to solve for all the missing side lengths for these triangles. So again, we're solving for every single missing side length. We do not need, we're going to do this without a calculator. Okay, so that's important. We're going to do this without a calculator, and we're going to look for the exact value, so no decimals. So let's think about which, well, first off, this triangle here, it's not labeled, but these are right triangles. But let's look up at the top. So we have this special right triangle. That's a 30, 60, 90 triangle. So what I'm going to do is I'm going to label that triangle that we're working with these sides, and we're going to use that information. Our goal is to figure out what A is. If we can figure out what A is, we can find the other two side lengths. So again, A is across from the side that's 30 degrees. So look at the triangle that we're dealing with. This side, it's across the angle that's 30 degrees, so that is A. A is 15. So remember the relationship here. So remember the hypotenuse is 2a. Well, 2 times 15 is 30. So the hypotenuse would have a length 30. So remember the side length over here, the long leg, is a times the square root of 3. And we just said a is 15. So that would be 15 root 3. There's nothing we can do to simplify that. So those would be our other two sides. Let's do the same thing with this one. Now this is our equilateral triangle. So remember for this one, let me go back up to our special right triangle. That's equilateral, 45, 45, 90. So this time the two sides that are your equal sides are side length of A, and the hypotenuse is A times the square root of 2. So this 18 represents the side that's A square root of 2. So remember, what we want to do is we want to solve this for A now. We didn't have to do that in the previous one because the previous one we knew what A was right off the bat. So to solve for A, I would divide both sides by square root of 2. Now we do have to rationalize this denominator, so I'm going to multiply the top and bottom by square root of 2. So we'd have 18 root 2 over 2. And let's simplify this even further. 18 divided by 2 is 9. So our A value, let's write it like this, would be 9 times the square root of 2. So now we have everything that we need. So remember, these two sides are A. So this side here, that's A, is 9 root 2, and this side here would also be 9 root 2. Okay, I want you guys to see if you can use that same concept that we've done now in these first two to see if you can figure out how to do letter C. So I'll help you get started. So when we're looking at letter C here, 24 is across from the angle that's 60 degrees. Let me erase. Somehow this keeps moving. Whoops. So now we're dealing with the side that's 60 degrees, or the side opposite that's 60 degrees. So that's the side that's going to be a root 3. So what we're going to do is we're going to take the side that's 24 and say that's equal to the side that's a root 3. So what I want you guys to do is I want you to solve for a. And then once we have that, figure out what the other two side lengths are based on the fact that, again, this is a 30, 60, 90 triangle. So this angle here would be 30 degrees if that helps to figure out what the other two sides will be. So I want you guys to solve for a and then find, again, the lengths of the other two sides. So go ahead, pause the video and hit play when you're ready to check your answer. All right, so I did my work down below the right triangle there. So I said again that a root 3 is equal to the side that's 24. So to solve for a, we would divide both sides by root 3. And then we have to rationalize the denominator, so multiply the top and bottom by root 3. So you get 24 root 3 over 3. Again, that can be simplified. 24 divided by 3 would be 8. So I would simplify to be 8 square root of 3. So on that right triangle, the side that's across from the 30 degree angle, that's your short leg, so that's going to be a. And the hypotenuse, remember, is double that. So the hypotenuse is going to be 2a. So we found what a is, 8 square root of 3. And so then if we double that, multiply it times 2, we get 16 root 3, so that's your hypotenuse. So that's how you'd go about solving a right triangle for finding those different side lengths when it's one of these special right triangles. And again, this only works when we're dealing with special right triangles. So that's it. That's our lesson on special right triangles. So good luck now as you work on your assignment.